Minasan, konnichiwa, Zamurai Engineer desu. So in this video, let us take a look on the realities on the ground with respect to construction. So civil engineer construction, we have what? Steel design. And in this course, we are actually talking about reinforced concrete and pre-stressed concrete design. So let's take a look in some construction fail that we have to avoid. That's why we are designing properly and planning it for construction purposes. So this one video, let's take a look. Okay, so wheelbarrow. Okay, so did you notice that the wheelbarrow comes in? We have what? The red circle here. Manual. What? Carrying, manual carrying using wheelbarrow of the what? Concrete mixture. No? So take note of the red circle there. So the wheelbarrow, and then it what? It fell. All of the slab. Slab meaning, when we are talking of slab, that is the flooring, right? The floor with concrete. So all the floors with wet concrete, they fell on the ground. Okay. Actually, this is the flooring for second floor, or the roofing for first floor. The same function. That slab has the same function of being a flooring for the second floor and the roofing for the first floor. Okay. So as you can see, there are still reinforcement standing up. Okay. There are still reinforcement like this standing up, meaning to say second floor is being prepared. Those extra steel reinforcement are for second floor purposes. The second floor construction is being prepared already. Okay? Because if this building is only a bungalow type or one-story building, no need for extra reinforcement to protrude above the roof. So meaning to say, this is not the final roofing, but this is for the roof of first floor and flooring for second floor. That is the function. Okay. So take a look at the square red indication here at the left side of your screen. What happened? Take note of that red circle. So the pulse work moves. Okay, the pulse work moves. There is no even simple protection for stability of pulse work. Take a look. Repeat here in this red portion. Okay, take a look on the red portion. The legs of the pulse work moves. Okay. Take note of the failure. No? Take note of how the construction is done. Totally. And take note of the two engineers. Okay, they know the two engineers, the yellow and the pink one. No? Okay, they are included in the failure. Take note of the green circle. These are the support mechanism to the ground, directly to the ground, to the ground, to the ground, to the ground, and this is the side extension, connecting some. Take note of this. The slab is actually too high. It is actually what? More than the average height of 1 story. This is more than 3 meters. This is more than 3 meters. The height of the slab is more than 3 meters. The usual 1 story height is at about 3 meters, plus minus something. No? But there are buildings like, for example, in our school here, in our school. So we have about what, 5 meters inside this office, 5 meters. Okay, but the next floor are about 3 meters high. Only in the ground floor that the height of the flooring is of the story is 5 meters. The succeeding ones are about 3 meters. Okay, so similarly here, it is about 5 meters. This height is about 5 meters. Taking for consideration the height of the of the construction worker here. Okay, so the height of construction worker is this high. So the height of construction worker is about what? 1.7. I am 1.7 meters. Okay. My height is 1.7 meters. So less than 2 meters. So if this is 1.5 meters, 3 meters, actually this is more than 5. No? This is about 7. This is about 7 meters high. Okay. It's about 7 meter high. So I don't know because these are Indians. I don't know if Indians are having average height of 1.7 meters or 1.8 meters. Some of the Indians have height more than 1.7 meters. I think the average height of Indians are better than our country, no? Than our citizen or Pinoys. No? So I think the average height of Pinoys 1.5 meters. So 1.5. No, 1.7 to 1.6, 1.65. The average height of Pinoy is 1.65. That is equivalent to 5.5. That is equivalent to 5.5. 1.65 is 5.5. Okay? But I am 5'7", so 1.7. I don't know. I think the average height of Indians is higher than our average height. So if that is correct, this is about 7 meters, I think. Okay. So we can actually use our what? I can more or less estimate this properly. Okay. Let us estimate this properly because there are what? We can actually do it properly. I will use my measuring scale. So this is 55, and the height of this is 113. So 55 and 13. Okay, so Let us compute. So I will compute properly. Much like in survey, di ba? Survey of audience of ano. We can do it properly and with better accuracy than other people. So we can, for example, the height of one person is in my monitor. I measure the height using this one. So that is 13 mm. So 550 is the 550 mm, the total height of the building. So I will estimate. Okay. So divide by 13. So we have, and the height of one person is what? I think 1.7. So let's say 1.7 meters. Okay. So this is about 7 meters. Okay. So the height of this slab is 7 meters. More than, I think it is actually more than 7 meters. So 7.2. So something like that. So that is the engineer's estimate of how to do it. So if you can see a picture or video of a crowd and they are estimating it to be 70,000 people attended the rally, so we can estimate that in terms of area. Okay, so you have to measure the actual picture or video. Okay, so let's take a look what will happen to the green portion. To the green. What happened? So the support. Take note of the what? Of the slab. Okay. So if the height is 7 meters, more or less, what can you say about the length of the slab? This is one column. Okay. Column is the English word for poste. The English word for haligi. No? Haligi, column, post. So one column here, and the next column is actually there. So take note here. This is the protrusion of reinforcement from one column, and this is the protrusion from the next column. Imagine how long. This is 7 meters. So I will measure. I will measure about how much. I will estimate about how much this is. Okay. So 40. So I will compute. I will use calculator. Imagine 18 meters. Okay, imagine 18 meters. Yes, 18 meters. Imagine it, 18 meters. What do you mean by 18 meters? Okay. Can you imagine what is 18 meters? So room, our regular classroom in our school is 8 by 8. 8 meters length, 8 meters width. That is our regular classroom in our school. Okay, 8 by 8. This is 18. No, the length from one column to the other, 18 meters. Imagine 3 rooms. Okay, 3 rooms. So 18, so 2.5 rooms. Okay, because 18 meters, 2.5 rooms. Okay, imagine the length. This is what long span. This is what we call. This is what we call in real construction long span. This is a long span. Okay, so meaning to say, we can actually the average. Okay, the average length of or the distance between column to column. Average. We're talking average. It could be about 4 to 6 meters. Imagine if you do it what 4 meters column to column distance. This will not fail. This will not fail during the construction. Column to column distance 4 meters. For this length, we need another column here and another column here. So 18 divided 4, that is 4.5. That is an ideal column to column distance. Okay? 4.5. Because 4 to 6 meters, that is somewhat allowed in other code. Okay? In Indian code. And I think in UK, 6 meters are allowed in their code. Okay? Take note, each and every country has different code. So take note of that. So if you, that is another reason why I do not use Indian author, because maybe they are talking about the Indian codes. So I don't know if they are talking about Indian codes. Therefore, I will have a different interpretation, because we are using in the Philippines, we are using our NSCP and we are using what? ACI. So those two are our commonly used codes in the Philippines, in our country. Okay? So that is another reason why I do not choose Indian author, if possible. So 18 meters, imagine that. Take note, from this column to the next column going to the back, or this one going to the back, this is about 4 to 5 meters. This is correct. This is allowed. So from this column to the next column, this is about 4 to 5 meters. So from this column to this column, this is about 4 to 5 meters. But this column going here, this is a long span. So this column going here, this is a long span. So I am talking of columns for building. That is not the same when we are talking of columns for bridge. Of course, the columns for bridge are longer. Okay, the requirement for columns of bridge is very long. Okay, so for building, so take note, this column and the next column to the next, going to the back portion of the, going to the rear portion of the building, it's about 4 to 5 meters. Okay, but this column again, going to this next column, this is the next column. So, okay, this is also another what? Long span. This is another long span. This is the next column. This is the next column. This is about what? We can again estimate. We can estimate. The length of that is, so let's compute 80 . So we have what? 10 meters. This column to the next column here is 10 meters. And the front columns, this one going to this one, they are what? 18 meters. So therefore, this column going to this column is about 4 meters. 4 plus 10 plus 4 is 18. That is how the columns are designed in this construction, in this building. Okay, so if that is the case, you will need more false work and form works in order to support the wet concrete until the time that the concrete itself can support its own weight. Okay? Okay? So imagine that. Take note of this part. This is supporting the slab above, but take note of the angle. It is, I think, better if the angle is going like this one, like this. This is the correct angle of support, unlike this one. But they did not do it because I think it will become what? It will become obstacle because they are what? They are having what? They have an equipment here. Another mixer, diba? Can you see the mixer? There is a mixer here that will produce a concrete mixture and will be what? Will be brought above using this. I think this is there is a ladder here, no, or pulley here in this portion going to the next mixer above. So if you put the correct angle here, the support must be going this way, in this direction, not in the opposite angle. This is the opposite diagonal. So that's why it is very easy for this part. This is the first part. This is the part who first experience failure. This is the first part. This aggravates. The failure of this part aggravated the failure and actually carry or pull the failure of the other formworks and false work. Okay, so this one, this specific angle here, the diagonal, no? The proper diagonal, I think, is going here, but it will what? Obstruct their mixer on the ground. Right? Also, take note. This is the first. This is the first part who failed. And actually, we don't know about this because inside this also, they are almost failing at the same time. This part, no? This one, they are almost failing at the same time. But I think this part pull, give the heaviest pull in order for all of the false work to fail. Okay. Take note. Okay. It is almost laughable. It is almost a funny video, but as an engineer, We cannot laugh at this type of tragedy. We know the responsibilities. We know how many people would be injured. Okay? We know how costly it would be. Okay? That's why we have to prevent this from happening. Imagine if you are the engineer and you are the one who will sign the construction. Okay? So, and imagine if you are fresh graduate and just passed the board exam and you are going to sign, and then in the following year you will be what? You will be in prison for how many years? Oh, just like that. Just like that. Okay? That's why we need more respect from the government and officials alike, because we are the one who will bear the responsibility. Okay? You cannot say this failed because my teacher did not teach us the proper way. That is not a reason in order for you to be exonerated from criminal liability. So you will go directly to jail if that is your reason. Okay? So it doesn't matter even if your teacher did not taught you about this or not, or something else. No? So you will have what? You have the same responsibility if you sign the construction as the project in charge. So you are liable. These two engineers are liable, and at the same time, they what? They will get injured. Take note, if you are an engineer, you have to take note of all of these things. You have to see it with your own eyes. So these two engineers are doing their job properly. Okay? They are looking, inspecting, okay, discussing something, but they did not, or they failed to take note of the magnitude and importance of pulse work in this regard. Imagine this slab has full of steel reinforcement. There are so many reinforcement laid down on this slab. Actually, double. Okay? Double reinforcement, left and right, horizontal, X and Y axis reinforcement. There are plenty of reinforcement, meaning steel reinforcement. But because it fails, what can you feel about it? What can you feel about it? Can you compare now? Now, can you compare the relative weight of concrete mixture and steel? Okay. Do you have now the proper perspective of the comparison between the weight of the material? Because the weight will become a load later on. Okay, later on. It is actually a load, and you are actually going to compute it. And in your what? Structural theory, you are actually given a chance to compute, calculate the load of a given element. For example, simple beam. I hope we are going to understand each other when we talk simple beam, when we talk cantilever. Okay? What are the three types of beam? Cantilever beam, simple beam, and fixed beam. Okay? So, it seems you already forgot. So, you have to review your theory of structure. Okay? Okay? So, what can you say about this? I will call up your attention one by one regarding the type of structural element and their support. Okay. Give me 2 minutes to connect my laptop to the socket.
Para daw mamaya, makasaksak din daw siya ng pati. Kasi yung window ng pati, extend, mag-share daw.